Hello, everyone. I'm Stephen Englehardt from Princeton University, and today I'm going to be talking to you about how the web privacy problem is a transparency problem and show you the work that we're doing to improve that. So when you're browsing the web and you visit a site like, let's say, the New York Times, you're not just visiting that first-party site, right? But you're visiting all of the included third parties on that site. And this might be people you recognize, like Facebook provides social buttons or YouTube provides video. But what about the advertising companies or the analytics companies and so on that are not immediately obvious who they are to the consumer? Well, they could be anyone from this graph, right? It could be, users might be able to figure out who they are if they use an extension like Ghostery, but what are their privacy practices? What are their tracking practices? Which technologies do they use? That's not really obvious, right? Because the web lacks transparency. But what I'm going to show you today is how we're changing that. And I'll show you also how we already have. So throughout this talk, I'm going to talk about reference back to our paper from 2014 called The Web Never Forgets. It's a paper that looked at persistent tracking mechanisms, but in particular, I'll focus on canvas fingerprinting. If you're not familiar with canvas fingerprinting or that type of tracking mechanism, essentially, instead of setting some state into the browser or setting cookies on the browser, you can look at the browser's properties and use that to uniquely identify someone across different websites if you're a tracker. So in 2012, there was a paper called Pixel Perfect, which talked about canvas fingerprinting. Sometime over the next 2 years, AddThis, Ligatus, and a bunch of other companies, about 20 of them, started using this to track users. In 2014, we went and did our own measurement of this. We wanted to see who was doing it, where they were doing it, how the technology worked, and so on. And then, shortly after releasing our paper, we saw a bunch of news coverage, and this really surprised us. We didn't expect such a response from the news and such a response from users. Things like ProPublica, BBC, and so on. And then, just 2 days after all that news coverage happened, AddThis, who was the largest provider, they provided canvas fingerprinting on 95% of those sites. They stopped doing it, and as well as Ligatus, which was the second largest provider. So the thing to point out here is that canvas fingerprinting was a known technique for 2 years, but in just 2 months following our measurement work, people stopped using it. So why was that? What was different about our work than just, say, having canvas fingerprinting be known and people knowing what it was? And the key point is that our work removed the information asymmetry between trackers and really the rest of the web. So we got, like I said, we got a bunch of news coverage from that, from different companies. And then we saw users take to Twitter to complain about it, as you can imagine. We saw people say, hey, you should remove AddThis from your site. This is a way of stalking. This is, the first parties here are violating my privacy. We saw people just complaining about it, and then we also saw someone say, I feel gross because I had to use AddThis to share this, but everyone should know about canvas fingerprinting. So there was definitely a big response on Twitter. And it wasn't just on Twitter. We also saw people, for example, complaining to Mozilla and saying, why doesn't Firefox protect me from this technique? And we even saw that it was beyond just users. It was also between trackers and the sites that they track on. So ProPublica focused on YouPorn, which they wanted to point out that this tracking's happening there. And YouPorn responded to them and said, hey, we didn't know AddThis was doing this. Could you let your readers know, I guess, that we've removed AddThis from our site? So we see that transparency is effective at returning control to the users and the publishers of knowing what's going on. The users can see what kind of tracking technology is being used on their site, and then they can make decisions, right? They can complain or see what kind of tracking technologies are on the sites that they visit, and then they can complain to the first party or to the site that they're visiting. They can choose not to go there, right? They can have some control, which they didn't have before when they didn't have that knowledge. And automated large-scale measurements like the one we did can help provide this transparency. So at Princeton, I'm going to talk about a couple things that we did to make this happen. We developed OpenWPM. So this is really like the first infrastructure that can run on a bunch of sites, or run a real browser across a large number of sites. And we're using it to run our own monthly million-site measurements of this kind of thing. So we'll also build some analysis on top of that to look at who's fingerprinting on these sites, who's tracking, and so on. So I'm going to walk through a little bit how OpenWPM is built and how it works. And then I'll go into a case study of how it makes things a lot easier and show you how we can scale this up to all different kinds of technologies. So OpenWPM runs Firefox. And the way that we do it is we run it with something called Selenium. This basically lets us tell the browser, hey, you should go to this website, you should do certain things when you're on the website. And we run everything through a proxy, so that lets us record all the traffic or all the communication between the browser and the sites that we're visiting. And then we also have a Firefox extension based off of fourth party. So if you're not familiar with that, it's another web measurement framework, probably the most well-used prior to us building our infrastructure. And we took all the features that had, added some more to it, and built it right into our platform as well. So we give a researcher access to these different locations in the browser, and then we wrap that up in something called a browser instance. And as you can see here, we're basically able to run multiple instances of Firefox or multiple browser instances at the same time. So when we do our own crawls, we run it over, say, 20 browsers, and each one has their own instrumentation. So you can easily scale this up to do measurement on a lot of sites. And there's a couple things this lets us do, right? We can keep a profile consistent through crashes or freezes, so we can keep the same cookies as we browse to different sites, just like a real user would. We can also do things like run this with extensions or privacy features, see how well they work, see if they're actually protecting users or where they're falling short. And if there's any new web technologies being used for tracking, like WebRTC or audio and so on, we can take a look at that. So this is already used by 7 research groups, and you just heard a great presentation by the Web Privacy Census guys who do it. But it's also used beyond academia from journalists and regulators. So I'll talk a little bit about the measurements we're doing. We're going on monthly crawls of 1 million sites, and we're collecting things like all the JavaScript calls that might be used for fingerprinting, or all the JavaScript files on all of those sites, so we can go and check out what's actually going on later on. And we're also looking at the requests and responses and different storage locations in the browser. And this lets us do a bunch of things, like see how effective privacy tools are, like Ghostery or AdBlock Plus, see how effective browser protections are, see how JavaScript might be used for tracking, and also look at tracking practices. So now I'm going to give you 2 quick case studies. I'll go through Canvas before we built OpenWPM, and I'll go through WebRTC after. So Canvas, like I said before, is just a site goes and draws text to the HTML5 canvas, and that text looks different on different machines, but the same on the same machine. So it's useful if you want to differentiate between different users, but keep, know who the same user is. As you can see here, the differences can be quite large. This is just a visualization of differences between different machines compared to each other. And I want to give credit to all the co-authors on this study. I was just one part of it. So we worked with people at KU Leuven and a bunch of other co-authors at Princeton. So the way that this works is a website will draw a bunch of text to the canvas and make it overlapping and try to maximize the chance that it's unique, and that's what you see visualized up here. And if we want to measure this, we have to do a few things. We first had to write a Firefox patch to look for when these methods were called, when write text or when pulling back the canvas as a string, when that happens. We had to write automation with Selenium to go and run this across a bunch of sites and build that from the ground up. And then, of course, we had to write some analysis code on top of that. And now I'm going to show you how things were easier to measure another technique that could potentially be helpful for tracking. If you're not familiar with WebRTC, WebRTC for using it for local IP discovery, essentially it adds some networking capabilities into the browser that you can access from JavaScript. And basically, you're able to get the user's local IP if they're behind a NAT. If you're a home user, that might be something like 192.168.1.2, but it can be useful for tracking. You can think of it like that. So I saw a tweet that this was happening, and I said, oh, we can measure that. We can take a look at that. This won't be that hard. So I was able to add just a single line of JavaScript into our next crawl to do this. So this is the same thing I have a method here that allows me to look at anytime anyone accesses WebRTC, I can see that, right? I can see what they're setting and what they're doing with it. And it's the same method I use to look at who's doing things with Canvas, right? So it's just one added line of code to run our crawls. I had to write some analysis code on top of that, very similar to Canvas, right? With Canvas, I wanted to know who wrote text and who read back from it. Well, here I do similar things to see when this technique is being used. And I found this happening on a bunch of sites beyond the New York Times, right? The New York Times actually stopped doing it. So 121 first-party sites, and 24 of those were unique, only one of which is blocked by, say, AdBlock Plus or other similar privacy tools. So even if you're using privacy tools, this technique may still be able to run on your machine. And I guess the point I want to make here is that web measurement gets much easier with OpenWPM. Instead of writing a Firefox patch, we could just write a single line of JavaScript. And instead of writing automation with Selenium, we could just use OpenWPM. And of course, we still need to write the analysis code. You always need some extra human component in there. But the first two steps got a lot easier. So where do we want to go with it? We think we can use this to inform the public, right? Let people know, hey, here's what's happening on the sites you're visiting. Here's who's doing canvas fingerprinting. And we think that'll really help people understand what's going on when they're browsing the web. We want to provide data for privacy tools. Disconnect, which is a privacy tool like AdBlock Plus or like Ghosttree, they actually ended up taking the scripts that we released as part of our Canvas study and building it into their own tool. So they protected against canvas fingerprinting. We want to provide that same kind of data for other privacy tools with our future studies. And we also want to make the data accessible to less technical investigators who may want to dig through it themselves, but maybe don't have all the skills necessary to dig through it at the same level that, say, someone who writes the code would do. And we'd also love to collaborate with people. So you can, the infrastructure is open source. You can go on GitHub, and I'll have a link on the next slide to use it. You can download it, and if you see anything wrong with it or if you see new features, you're welcome to submit back to it. We also envision people using it to run their own measurements like the web privacy census. That's an awesome use case, and we really hope that more people start doing that. And then lastly, in the future, we hope that you'll be able to download our data and build some analysis of your own on top of it. We'll be going further with that in the coming months. So if you want to help us make the web more transparent, you can check out our GitHub repo to collaborate, or you can check out our research page. Thank you.